All right, today's stuff is called inductive reasoning. What is inductive reasoning? Inductive reasoning is making a conclusion based on observations and patterns. Next vocab word, conjecture, guys. It is a concluding statement reached using inductive reasoning. All right, so here's our job. It says find the next 5 terms of the sequences, then write a conjecture. So conjecture is basically how did you get the next term in the sequence. So we check us out, 38, 31, 24, 17. They're basically just subtracting 7 from each of the terms. So I'm going to write in the answers for you. Subtract 7, and so forth. So my conjecture, how did I get this pattern? I just simply subtracted 7 each time. Next one, 2, 5, 11, 23. This one's kind of tough, guys. They're doubling the previous number, and then they're adding just 1 to it. So if I double this guy and then add 1, 47. Double this, add 1, 95. And here are the rest of the answers. So our conjecture, double the previous, add 1. Double the previous and add 1. Number 3, 1, 4, 9, 16. They're squaring each of the numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared is 25, 6 squared is 36, and so forth. 49, 64, 81. So squaring the number is my conjecture. Number 4, they don't want to deal with numbers. You can have letters in here as well too, or times or months or whatever. A, D, G, J. For this guy, they're taking the previous letter and 3 letters. So you're just going to add 3 letters to the previous letter. So the third letter after J is M, then it goes P, then S, then V, then Y. So previous letter and 3 letters. Number 5, 7:30, 7:55, 8:20. If you check that out, guys, they're just adding 25 minutes to each time. So if I add 25 minutes to 8:20, that's going to get me to 8:45. 25 to that is 9:10. And I'll just give you the rest of the answers here. 9:35, 10 o'clock, and then 10:25. Add 25 minutes. Last one. This one is super sneaky, guys. 3, 1, 4, 1, 5. There is no pattern. If you check this out, this is pi. All right. It's 3.141592653. That one was tough. You will not see that one on a quiz or a test. That's just kind of a sneaky one. Next page. Most of the page talks about counterexamples. What is a counterexample? It's an example that shows a conjecture is false. So basically, we're going to be given a statement, and we got to decide whether the conjecture is true or false. If it's false, I have to give a counterexample. Some of these are tough, some of these are pretty straightforward, but let's see how we can do with these ones. So number 1, So the sum of any two consecutive integers, remember integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot, 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 is always odds. So if I take any two consecutives and I add them up, will I get an odd number? Let's try it. 1 and 2 is 3, 2 and 3 is 5, 3 and 4 is 7, 4 and 5 is 9, 5 and 6 is 11. So yes, this is true. There is no counterexample because it is true. Number 2, the product of two numbers is always larger than either number. Well, false. Here's why. I can take any two numbers and it has to be larger than either number. Well, that's not true because check this out. If I take number 2, I times that by a half, that comes out to be 1. But check this out. This number right here is not larger than the answer. So that's why it is false. The product of two numbers is always larger than either number. False, because the answer is greater than this number right here. Number 3, the product of two perfect squares is always a perfect square. So your squares are what we did on this page over here. These are your perfect squares, number 3 on the previous page. So I multiply these guys. Do I get a perfect square back? Let's check it out. 1 times 4 is 4. Yep. 4 times 9 is 36. Yep. 9 times 16 is, 90 and 54, 144. And yes, it's a perfect square. So the answer is yes. If you multiply two consecutive perfect squares, you will get a perfect square back. So the answer to number 3 on the back page here, guys, yes, that is true. Number 4, if the area of a rectangle is 6 square meters, so just kind of draw a little picture to help you out here. We got a rectangle, and they're saying the area is 6 square meters. Then the dimensions must be 2 by 3. Well, if I put a 2 here and a 3 here, yeah, 3 times 2 is 6, but this is false. We could have also used a dimension that could have been 6 meters by 1 meter. Yeah, 3 by 2 works, but also a 6 by 1 also gives you 6 square meters, so the answer there is false. Number 5, divided by 2 produces a number less than the original. False. Here's why. Now, the numbers could be negative, right? So if I took a negative number, let's say negative 8, and I divide that by 2, that comes out to be negative 4. But check this out. Negative 4 is not less than negative 8. Negative 8 is less than negative 4. So that's why that one is false. That is my counter example. Number 6, vertical angles are never complementary. You better know the vocab, guys. What are vertical angles? What are complementary angles? Remember, vertical angles are across from each other. They measure the same. Complementary angles have to add up to 90 degrees. Well, and here's why this one is also false. It says that vertical angles can never be complementary. Well, what if I did this? Let me show you what it looks like visually. So these are my vertical angles, right? If I said this guy was 45 degrees and that guy is 45 degrees, well, check it out. They're vertical and both these add up to 90 degrees. So they are complementary. So this is my example for false. I could have an angle that is 45 degrees and another angle that is 45 degrees. Number 7. If A times B equals 0, then either A has to equal 0 or B has to equal 0. Yeah, you bet, guys. That's true. If you multiply anything by 0, you're going to get 0 back. So one of these numbers has to be 0 for that to be true. Number 8, more vocab. Two angles supplementary. Remember, that means they have to add up to 180 degrees. If two angles are supplementary to the same angle, they must be congruent. True. Here's why. Let's say I gave you an angle of, say, 95 degrees. Any angle supplementary to this angle must be 85 degrees. So two angles supplementary to the same angle must be congruent. That is true, for sure. Number 9, all state names have at least 2 syllables. False, there's only one. And that bad boy is Maine. Maine only has 1 syllable. Number 10, squaring a number and adding 1 will always produce an even number. False. Here's my counterexample. Let's say the number 10. If I square the number 10 and add 1, that gets me to 101, which is not even. So there's your counterexample to that one. And that is it. You can, on your own, guys, if you want to try to make your own conjecture, decide whether it's true or false. You had a couple examples there if you want to knock that out. If you want to, that's fine as well. And that is it for inductive reasoning and counterexamples.